Good morning, students. Today we'll discuss about the edaphic factor, that is the soil, as an important factor in the ecosystem. So, the edaphic factor, they deals with the different aspects of the soil, such as the structure, composition of soil, its physical and chemical features, and the galaxy of complex factor that constitutes the soil. So soil is usually defined as any part of the earth crust in which the plant root. The soil is constituted as a result of long-term process of complex interaction leading to the production of mineral matrix in close contact with institutional organic matter, both living and the dead. After a long time, the present mineral matter takes the modified shape which forms soil. The interaction among climatic, topographic, and biological factor pave the process of transformation and modification of mineral matter into the soil. So, the soil mainly has the following components, that is the mineral matter, then is the organic matter or the humus, then is the soil water, then is the soil air. The biological systems, that is the bacteria, fungi, algae, protozoans, rotifers, arthropods, they are also present in the soil. The soil is a result of actions and reciprocal influences of parent rock, climate, topography, plants, animal, and the age of the land. The withering is the process by which large rock are broken down into small pieces and converted into fine powder. This is a long-term process occurring mostly under the influence of climatic conditions of the area and hence called withering. The mechanical and the physical withering takes place by the movement of rocks with running water or ice and by the gravitational forces as landslide in the mountain region. The freezing of water in small crevices in the rocks may also exert enough pressure to break down rock into pieces. In hot deserts, large diurnal fluctuations in the temperature also cause breaking down of the rocks, especially exfoliation of sedimentary rocks. The chemical withering includes the hydrolysis, oxidation, and carbonation of mineral compound in the rock by the action of weak acids like carbonic acids. The traces of sulfuric acid and nitric acid also occur in certain regions and influence withering. The biological withering includes the action of the various organisms, particularly the lower plants, that is the lichens, mosses, which secrete various organic acids and produce humic acid after death and decay. These acids help in the withering process. On the basis of nature of transporting agent, the transported soil may be classified into colluvial soil by gravity, alluvial soil by running water, then plancial soil by glacier, large masses of snow or ice, and then Aeolian soils by wind. The nutrients required by plants are present in the top layer of the soil. This top layer is known as the feeding zone of the plants. The top soil is made out of most valuable natural resources. It is very fertile and usually lies at the depth of 15 to 20 centimeters over the face of the land. But we found an acute problem of soil erosion. It is a natural process. For the formation of uh, it includes formation of an inch of soil. It takes 500 to 1000 years, but the fertile soil is wasted or lost because of certain reasons. The scientists, they expresses soil erosion as a part of soil pollution. The soil erosion is called the creeping death of the soil. In the region with high density of population, there is maximum soil erosion. Repeatedly cultivation of land with some type of crop leads to soil erosion because of the problems by deforestation. The multi-purpose dams have been endangered. The soil erosion is the result of deforestation, flood, overgrazing, etc. Kind of soil erosion, they are mainly normal or geographical erosion. This type of erosion is caused by normal or natural condition without any interference of man. Second is accelerated soil erosion. There is no equilibrium between the formation and loss of the soil. The rate of soil loss is very rapid due to the interference of man and the animals. So the agents of soil erosion, they are the water erosion is caused by raindrop removes the soil. The thin covered form larger area are lost by the rainwater and known as the sheet erosion. When the sheet erosion takes place with full momentum, it leads to the cutting of the soil surface as the channels of streams. It is known as rill erosion. Several rills formed by the steep slopes of on wide channels of water leading to the gully erosions. The wind erosion in dry arid region, the soil is mainly sandy and the vegetation grossly inadequately. Wind in Rajasthan and other arid region cause loss of soil, loss of natural vegetation, cover of land due to deforestation and overgrazing. Mining activity leads to the dry and dust soil. With long rainfall, poor draining system and high temperature, water evaporates quickly, leaving behind the salts. In land around the ocean, generally the salt accumulates. Such salts are comprises of the chlorides, sulfates, carbonates, nitrates, potassium, sodium and magnesium. The pressure of heavy rain gravitational forces and other factors lead to the landslides and the slip erosion. So the loss of forest due to deforestation, rapid growth of the population, industrial activity, mining cause heavy flow of rainwater from the top hills. These causes the loss of soil. The soil erosion is mainly due to the wind and water. Thus, the soil erosion conservation methods should be through the protection of soil from the severity of raindrops, then to protect water from concentrating and passing through the slopes, to slow down the momentum of water flow through various scientific techniques, to plan out methods by which water can be adequately enter into the soil, the growing vegetation cover, and thereby to minimizing the wind velocity. The soil binders like the growth of grass can prevent the soil erosion. So when we look at the soil profile, the soil, it consists of various horizons: O horizon, A horizon, B horizon and C horizon. A horizon is the one where it is the topsoil, it is rich in organic matter and it is darker in color. Whereas O horizon is the topmost layer which is rich in humus. And B horizon, it is the subsoil, it is also called zone of accumulation. And the C horizon, it is the withering bedrock, the lowest most portion, and it is the present at the base of the soil profile. It is not having the humus or the organic matter, and the plants, they cannot grow in the C horizon. So plants, they grow in O and A horizon, and the roots, they are also present sometimes in the B horizon. So the soil is mainly composed of, as I've told you, minerals, water, gases and the organic matter. Minerals, they constitute about 40%, water constitute about 25%, air constitute about 25%, and the organic matter, it constitute about 10% in a loamy soil. But the condition, it is variable. That is, the organic matter, if the soil is not fertile, then the quantity may be as less as 1% to 5%. And if the water amount is not present, then it can be as less as 2% to 50%. And large number of the microorganisms, they are also present in the soil. So when we look at the physical property of the soil, first of all, the density of the soil is important. It depends upon the extent of withering and the particle organization. Then is the porosity. Porosity means the particles, they are how much they are present apart from each other. That is the space between the soil particle. It is the porosity. More the porosity, more will be the water holding capacity. Then is the permeability. It determines the movement of water through the pore spaces. Then is the soil temperature. It is influenced by the soil color, texture and water. It is affected by the climate and the vegetation type. The black soil, it absorbs most heat. Then is the soil atmosphere. The soil atmosphere, basically it is because of the oxygen, carbon dioxide and the nitrogen. So they are responsible for the maintaining the soil atmosphere, and it is influenced by the temperature, wind and the rainfall. The chemical properties of the soil. The chemical composition, the soil, it consists of various organic and inorganic compounds like calcium, magnesium, iron, aluminium, then sodium, potassium, traces of manganese, zinc, cobalt, copper, etc. So they all influences the pH of the soil. The organic matter, it includes the amino acids, aromatic compounds, the purines, the pyrimidines, the sugars, the alcohols, fats, oils, resins, waxes, lignin. So the organic matter and the humus formation, it will constitute the organic component of the soil. The pH of the soil, it is also variable. It varies from 2.2 pH to 9 pH. The soil may be acidic or the alkaline. So soil pH basically is because of the minerals which are present, and it is because of the vegetation type which is there. Then is the warm and the dry climate also affects the pH of the soil. The acidic soil occur in high rainfall regions. The pH, it affects the availability of the nutrients as well as the minerals. Then is the soil water. Different type of soil waters they are there. For example, gravitational water. Then is hygroscopic water. Then is the capillary water. Then is the combined water, and is the water vapors. The water vapors, they are basically the moisture. Combined water is when the water is bound to the soil, chemically bound to the soil surface. Then is the capillary water. It is the only water which is available for the plants. It is because of the air spaces in the porosity in the soil. The hygroscopic water, which is tightly bound with the soil particle, and the gravitational water, which move down freely under the influence of gravity into the lower water table. Then coming to the field capacity. Field capacity is the amount of water the soil it can hold. And field capacity, it is the capillary plus hygroscopic plus combined and the water vapors. Then is the wilting coefficient. It is the water left at the time when the plant permanently wilt, right? So the total water present in the soil is known as the Hollard term is important. Then is the water which is absorbed by the plant. It is the capillary water. The term is known as the chi salt. And the remaining water means the gravitational water, the hygroscopic water, the combined water. They all are known as Ecart. So these are various terms used for the soil water. Generally 25% of the soil water it is present in a good soil, loamy soil. Then next term is the soil humus. Humus, as you all know, that is the organic matter which is present in the soil, which is essential for the growth of the plant. So we have got three types of the humus. One is known as more humus, second is known as the modder humus, and third is known as the mull humus. More humus, it is the least decomposed humus. It is low biological activity in the soil. So litter of large thickness, carbon/nitrogen ratio more than 20, and pH is acidic. In the case of modder humus, it is a transition stage of decomposition. The litter is low thickness, 2 to 3 centimeters only. It is having a moderate humidified humus. CN ratio is 15 to 25, and the mineral organic complexes are weakly bound. And last is the mull humus. It is a fully decomposed organic matter, highly biological activity, dark humus. C by N ratio is less than 10, and pH is neutral. it creates a stable mineral organic complex. So the most decomposed is the mull and least is the more, and modern humus is intermediate between the two. So these are the three types of humus. Now coming to the soil enzyme, different enzymes, they are present in the soil because of the microorganisms. Basically the amylase, the catalase, the invertase, the dehydrogenase, the phenol oxidase, the urease, they are present in the soil, which maintains the pH of the